Okay, it's Mr. J. So, looking at a pattern, this is a linear pattern, and we're going to turn it into a table of values. We're going to turn it into a graph, and we're going to define the algebraic expression for it to find the whateverth term. So, here's a very simple pattern, 4, 6, 8, 10, 12. Hopefully by grade 8 you will recognize that this pattern is going up by 2 each time. That's cool. And we have 1, 2, 3, 4, 5 terms in this case. So I might give you a pattern like this, or it may be geometry. Think about our expanding robot. It might be terms of money. Think about what was her name, Ashley, that won the contest and had to choose between the $12 a week or the $20 a week, but the $12 a week also had a $400 sort of start money. So expect any of those, but the point is it's going to be a pattern that grows by the same amount each time. It's not going to be like +2 +3 or something like the Fibonacci sequence where it's sort of a strange growth, right? This is a linear growth. And we call it linear because when we graph this, it's going to give us a straight line, and I'll show that when we get to the graph. So first thing you might want to do is make a table of values. I mean, you can sort of go in whatever order you want, but you know, in terms of things that we learn, we generally learn sort of this table concept, you know, grade 3, grade 4, grade 5, and we don't really get to the graphing until later. So it's always going to be term and value, okay, but what those are may be different, right? In our case, our pattern is, we don't really know what it is. It's just a number pattern. So it just has 1, 2, 3, 4, 5 terms. So I'm just going to write 1, 2, 3, 4, 5 down here. In other versions or other different linear patterns, we had, like, you know, these were weeks, how many weeks she was getting money. They could be other things. Our value in this case is literally just a number, right? 4, 6, 8, 10, 12. In other situations, this might be money or the perimeter of something or the area or the number of blocks. It could be lots of things. In our case, it's literally just numbers. So there's our table of values. That's it. Table of values is great for recognizing patterns. For example, I may notice here, if I didn't notice already, that this pattern is growing by 2 each time. I'll also notice over here, if it was something with a different type of term, the term might be growing differently. In our case, it's just growing by 1. And it's also good for finding, like, you know, if I needed to find the 6th term, I mean, that would be pretty handy right there. But I want, in this situation, let's find the, I don't know, let's find the 100th term. So what is the 100th term is my question that I'm going to solve. My table, all of a sudden, it will work, right? But it's going to be a boring job, not very mathematically interesting. Okay, so that's my table of values. I've left a little bit of space there. You may remember why. If not, I'll tell you why shortly. Time to make my graph. Bust out my ruler. Okay, I'm going to put in my y-axis first. Doesn't matter which one you put in first. There we go. And I'm going to put in my x-axis down here. There it is. And there is my exciting graph. Okay, always going to put term on the bottom, right? Or, you know, whatever your number of weeks, whatever it is. It's usually sort of a time thing, or sort of the growth period goes on the x-axis, right? So this is my x-axis down here. And then on my y-axis, I'm going to put my value, okay? And in this case, it's literally just numbers. Other cases, it's money, it's the perimeter, it's the area, it's the number of blocks, whatever, okay? That goes on my y. Now, since I'm dealing with pretty small numbers, right? My biggest number is 12. My smallest number is 4. I'm actually just going to go up by 1s. All right, and it's going to make my life a lot easier. So, you know, this is 0. It already has a number. 1, 2, 3, 4, 5. And I'm going to stop sort of counting every spot. But, you know, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll probably stop there. Okay, of course, this is like a number line. It goes on forever, right? I mean, if this pattern continues, it's going to be an enormous number eventually. So I'm just going to put a little arrow there just to remember that. Now, on my term number, I'm only going to have to go 4 or 5 here, so I'll just leave 1 space as well. Okay, kids get into problems when they start leaving big gaps here because they count things wrong, or they leave 1 space to 1 and they leave, you know, 2 spaces to 2, and then things get complicated. Remember, this is 0. It already has a number. So if you leave 1 space to 1, you need to leave 1 space to 2. If you went 2 spaces to 1, if you left 2 spaces to 1, that's okay, but then you got to leave 2 spaces every time. And it kind of complicates things when you get to the slope. So that's why I've just left 1 space. If it allows you to, do it. Some people ask about the lightning bolt. Okay, so when they make their graph, and they know this is 0, which is right, and then they go lightning bolt, and they want to go right up to 4. Okay, but like why? I mean, you know, going from 0 to 4 doesn't take up so much space, didn't take up a lot of time. Just leave all that. The lightning bolt's useful if you're going to 7 million, because you don't want to have to count up 7 million and your graph paper is going to be enormous, right? But we're going to 4. You're going to 4, you're going to 10. I mean, just count up. It's not going to take a lot of time. All right, now just graph my points. So first term, value was 4. So there's term 1, right? Term 1, its value was 4, put a dot. Term 2's value is 6, put a dot. Term 3's value is 8. Okay, and I just keep making my way through. You don't really need 2 points. Once you have 2 points, you can make your line. But I mean, it's good to go a couple points in just to make sure you don't make a mistake. Like if one of my points was way down here, I'd be like, hey, wait a minute, what happened? And I could sort of check my data and figure it out from there. But that looks pretty good. Comes time to do my line. Line it up very carefully and plot my line through. Okay, you can go right through the y-axis. We know that we need to have that y-intercept, so I definitely need to go there, but why not go right through? All right, there's my line. Looks pretty good. I could quickly check what my 6th term was, 14, that looks good. I could even go to my 10th, right? I could theoretically go to 100 terms, but I need a big piece of graph paper. I'm not going to do that. That's where the algebra is going to come in handy. But there's my graph. Beautiful, okay? So now it comes to the algebra. So our algebra for a linear equation, we express like this, y equals mx plus b. And all those variables have something on the graph or in the table that they represent. The y is literally just the y. What's on the y-axis? Which number on the y-axis does this line up to? Okay. The m. Let's do the x first. The x again is literally the x. It's the x-axis. So it's what term I'm looking for, what term I'm checking for. So if we're looking for the 100th term, our x is going to be 100. Okay. We may also put in 5 because we want to check the 5th term, because we know the 5th term is supposed to be 12. So we can check our algebra with 5 in here, and our y should equal 12 if we've done everything correctly. Our m is the hardest one to find. I'm going to leave that for last. The b is the y-intercept. Okay, so the y-intercept is the point at which my line crosses the y, and I can see that right here. It's 2. All right? So I'm going to put that as 2. I'm going to use red for the y-intercept because we can find it a couple other places. Okay, but our y-intercept is 2. On to our slope, okay, which is our m. So when it comes to the slope, our key is looking at the rise, how much up it goes on the y-axis, versus the run. So rise over run, and the run is literally just how much it moves on the x-axis. So I could take any 2 points on this line that I have. I'm going to pick, what is this, point 2, term 2. So term 2, and its value was 6. And then I'm going to look up here at term 3, whose value was 8. And I'm going to compare those 2 points. You can compare any 2 points. You could compare the 2nd point with the 1,000,000th point. It doesn't matter. You're still going to get the same number. But, you know, it makes sense to look at 2 close points here. So my rise, and the mistake kids make is they count grid spaces. So they'd say the rise is 2 because it goes up 2 grid spaces, which in this case is correct. But if you went up by 2s or 5s or some other scale here on your y-axis, you're going to get the wrong number. So don't count spaces. Look at the value. I'm moving from 6 to 8, which is a rise of 2. Okay? So that's my rise. My rise is 2. It just happened to be 2 grid spaces because I counted up by 1s. So that's a good little tip. If you count up by 1s, you can count grid spaces. But if you go up by 2s or 5s or 10s or millions, whatever, then you cannot count grid spaces. You have to count the change in value. All right? And then my run is just the change in x, okay, the change in term, which is from 2 to 3. So that's just a change of 1. So my run is 1. And 2 over 1 is just the same fraction as 2. If you divide 2 by 1, you get 2. So that is my rise, or sorry, my slope is 2. That makes sense, right? The slope of this is 2, okay? So now I have all my numbers. I got all the numbers I need. And I plug them into my algebra. So y equals mx plus b becomes y. I still don't know. That's what I'm looking for. I'm looking for what the value of my 100th term is. So y equals, m's my slope, which we discovered rise over 1 was 2. So it's 2 times, I'm just going to use brackets here. If you want to put the time symbol in, you can. 2 times, and I'm looking for what x? I'm looking for the 100th term, so I'm going to plug in my 100. Okay, and we can check for other terms here. So 2 times 100, and then my y-intercept is 2, plus 2. So the answer to this is 202. So that means that the 100th term is going to have a value of 202, which makes sense, right? I can check my algebra y equals mx plus b for the 5th term just to make sure it's working. So my slope is still 2, right? At any point, my slope's not going to change. And my x this time is going to be 5 because I'm looking for my 5th term, so that's 5 on the x, right? And my y-intercept is still the same. It's still 2, so plus 2. So hopefully, our 5th term should be 12, because 2 times 5 is 10, plus 2 is 12. Let's check if that is true. Is the 5th term 12? Sure is. Okay, and there it is in my table as well. You can actually find all the algebra from the table. You don't even need to make the graph. We do need to make a graph because it's part of the grade 8 curriculum, but I can find those numbers in here, okay? The y-intercept we discovered was 2, but it's really just term 0. If I fill in my table and put in term 0, and I say, what would term 0 be? Well, I'm going up by 2 each time, so to get from something to 4, by adding 2, I need that to be a 2, right? Or you could think it's taking away 2 each time, whatever works for you. But there it is. There's my y-intercept. It's term 0, it's 2, okay? Same as we discovered on the graph. I could also just find it here in my pattern. Just go back one more value. That's term 0, that's my y-intercept, all right? So that's where I can find the y-intercept. I can also find the slope in here, right? The slope is rise over run. And the rise is the change in y, the change in value. So if I look at value and I look for what the change is, it's plus 2. That's my rise. And our run is the change in x, right? So if I look, and that's our term number. So if I look at term number and see what the change is there, it's plus 1. That's my run. So I can actually get my y-intercept and my slope, 2 over 1, from the table of values. Kind of cool. I can also see it here. There's my rise, and my run is just how many I'm changing in terms. So this is term 1, term 2, term 3, so that's just plus 1, plus 1. So I can actually get my rise over run and my y-intercept just from the list, which is kind of cool. When it's something like a geometric pattern, like let's say I was looking at something like this, oops, I could also, if this is term 1 and this is term 2, I could just say, okay, well, what would term 0 look like? And it would be 1 block. So that would be my y-intercept. What's my growth? I'm adding on 2 blocks each time. That is my rise. Oops. And a change of 1, that's my run. Plus 1. 2 over 1, y-intercept. Kind of cool. So yeah, that is a look at this. The only other things you might want to think about is sort of where you might have a negative slope. Okay, that we're not going to do that in grade 8, but it's something to think about. Thinking about where these letters come from, like why do we use y and x? Okay, when mathematicians were coming up with variables, they started with like y, x, z, letters at the end of the alphabet. And so that's why we use those, and that's why they're on graphing, y and x. Why they have b as a y-intercept is because the next variables they needed were y-intercept and x-intercept, and they just called those a and b because they were furthest away in the alphabet from x, y, and z, which is kind of cool. And then they needed this slope variable, and they chose m just because it's like in the middle. They wanted it to be different than a and b, which had specific roles, and they wanted it to be different than x, y, and z, which were at the end of the alphabet, so they just picked a letter in the middle of the alphabet. But some kids like to think of a mountain, right? Like a slope on a mountain, and that's a way of remembering that m is for the slope. So hopefully that video is useful. Pretty long one, but yeah, good luck on our test.